In this problem, you're going to be sitting at a traffic light waiting for the light to turn green so that you can accelerate through the intersection. Now, if we assume that you start from rest, that is, your initial velocity is 0 meters per second, and you're going to accelerate at a rate of 4 meters per second, or 4 meters per second squared, through a 30-meter wide or long piece of intersection, how long does it take for you to travel through that intersection? So if you want to think of this in terms of a picture, if this is your initial velocity, which we said is 0 meters per second, and you accelerate through a distance of 30 meters, notice that we don't know what the final velocity is, although we could calculate it. Now notice a few things. Your acceleration is going to be in the positive direction. Your velocity is also going to be changing in the positive direction. So your acceleration and velocity are in the same direction. So in this case, the car is going to speed up. Now the kinematic equation that we would use to solve this problem looks like the delta x equals our initial velocity times time plus 1/2 the acceleration times time squared. Now in this case, our initial velocity is 0, so the distance that this object travels is going to be equal to 1/2 the acceleration times time squared. Now, I'm not just going to plug in the numbers that I know, I'm going to solve my equation for the variable that I'm looking for, in this case, t. So in order to do that, the first thing I'm going to do to both sides of this equation is multiply each side by 2. And by doing that, I can cancel this 2 out here with that 2, and the equation I'm left with is 2 times delta x is going to equal the acceleration times time squared. Now I'm trying to isolate t, so the first thing I'm going to do now is divide both sides by my acceleration. When I do that, notice that this term cancels out with this term, and what I'm left with is t squared equals 2 times the distance divided by the acceleration. Now, the next thing I need to do to both sides of this equation is take the square root, because I'm looking for t, not t squared. And now when I do that, take the square root of both sides. The square root of a squared number is just the number itself. And in this case, this is going to equal 2 times delta x divided by the acceleration. Now, in this case, we know that the total distance this object travels is going to be 30 meters. And the acceleration over that 30-meter distance is going to be 4 meters per second squared. And you're going to take the square root of that entire number. Now, when you do this, what you should get is 60 meters divided by 4 meters per second squared. And you're going to take the square root of that. Now, before we continue, what I'd like to do is just take a closer look at the term inside the radical. So that term, 60 meters divided by 4 meters per second squared equals 15 meters divided by a meter per second squared. Now the first thing I'm going to do to make sense of this unit is I'm going to multiply the bottom by its reciprocal, in this case, like that. And if I multiply the bottom by this number, I need to multiply the top by this number, because notice now this is really just the number 1, and that's why it's a legitimate mathematical operation. Now notice this meter cancels out with this meter, and this second squared cancels out with this second squared, and so what you should see is that this works out to be 15 meters times second squared over meters. And when you simplify that, you should see that this meter cancels out with this meter, and what you end up getting is 15 seconds squared. All right, now we're going to take this number and insert it back inside the radical and simplify this problem. So now the time is going to equal the square root of 15 seconds squared. And just to make a little bit more sense of this and brush up on your math skills, this is really going to equal the number 15, or the square root of 15, times the square root of seconds squared. And when you take the square root of 15, you get the number 3.87. And notice that when you take the square root of a squared number, you get just the number itself, which in this case is a unit, and in this case it's seconds. All right, so this is the time it takes for you to accelerate through that 30-meter wide intersection at a rate of 4 meters per second per second.